Hello everyone! What if you need to build, say, a nuclear reactor? What would you do? I'll tell you a story. A certain financial committee gathered regarding the construction of a nuclear reactor. They summoned experts, a scientist, to explain to them. He spoke, talked about various milestones, justifications, project details, and so on. The discussion lasted about 2 minutes, because it became clear that half of the people didn't know what a nuclear reactor is, and the other half didn't understand why it was needed. It's difficult, not progressing. There were a few more items on the agenda. They included them so they wouldn't have to gather the committee twice. Building a bicycle parking lot and purchasing kefir grains for this meeting. There were a few more opinions regarding the parking, as people have seen it and roughly understand what it's about. The discussion turned to what kind of roof it should have, whether it should be glass and beautiful or aluminum so it doesn't get too hot. Or maybe iron, which is cheaper. Well, they discussed it for 40 minutes. They reached an agreement. Then they moved on to coffee. While not everyone was familiar with parking and some doubted their expertise, there were no doubts when it came to coffee. Arabica, Robusta, blends, single origins, or the discussion flowed for about an hour and a half like a river. But regarding the reactor issue, nothing was resolved. Somehow it happens. They like it. For example, I'll tell another story. The developers found a problem, went to the managers, who called a meeting and started discussing. They explained the problem. Later, one thing led to another, and somehow it went on. Risk assessment and risks. Jokes and banter. The meeting went off track, 2 hours wasted. In the end, the managers are satisfied, but the developers are puzzled. How does this happen? Why? Why do people shy away from complex problems? This trait was noted by Norcott Parkinson. In 1957, he described in his book, calling it Counter-Reality, that people tend to spend more time on unimportant issues. And what is System Design 3? When you come to an interview, they ask, how would you build Uber? Or Facebook? How would you design YouTube? It sounds like the ramblings of 1,000 people. Hundreds design these systems, and we need to design something in an hour, like draw it. What is it about? If we go to a system design interview in the country, the interview includes requirements. Well, we take any hack rank, divide it among other things, and the task is usually described quite well. There are some input parameters, there is an example. But there, what should be, what the task gives as output, what answers, that's what System Design 3 is about. The requirements are extremely unclear. That is, I have not seen a single interview where you came in and they said, well, they explained the requirements so that you immediately understood what to do, or it was clear. At least what you should do today is extremely vague. If you take a solution, then during the interview, it can be objectively evaluated. Yes, that is usually you even see the solution as just very poor. That is some kind of brute force approach, and it doesn't meet the timing complexity for the interview. It's bad. You are looking for the optimal solution, right? But in the interview system, it's not like that. And all solutions are subjective. They are subjective because everything depends on the regulations that were mentioned to you today, which you clarified, I hope. And on the justifications for your solutions that you applied. That is, each component needs to be explained why it is there. And if in a coding interview, communication with the interviewer is important, meaning you need to explain your thoughts, the steps of your solution, then in a system design interview without communication. You might as well end it. If you didn't ask anything, you will do something completely wrong, or you won't do anything at all. This is the sacred meaning. Communication is super important. If we take a look at the reasons why people are rejected, based on the results of system interviews, they will be approximately as follows. Meaning the first candidates do not take on leadership system. The design interview is your benefit, it's your talk, it's your performance. You came there to show your level, to demonstrate your skill, to show how you can design systems. You explain to the interviewer how the system should be and why, clarifying with them along the way some requirements or at the beginning. It's not like that anymore. You can consult as with a colleague, but overall, this is your process. You are showcasing yourself, and it should look like that. From that point of view, what you are explaining is how the system behaves, and what you should not apply next is about trade-offs. There are candidates who could not explain the pros and cons of the components they did not choose. They are less valuable. Let's say, what kind of technical leadership is there if your answer to any question is Kafka? People who do not clarify requirements start writing a solution right away. It's like the honest student syndrome, who hears the task and already roughly understands what needs to be done, even though the system is so extensive. Yes, if they told you to make Google Drive, it doesn't mean you understood the task. It means you at least found out what we are building today. And usually just start sketching things out. You sketch, like someone who thinks they're the fastest in the world. They ask, what's 17 multiplied by 56,223 right away? That's incorrect, but very fast. It's the same story. You shouldn't do it this way the next. Situation involves people who show promise. Now, but still, they don't shine. Like discussing an advertisement with you. What was missed? Not asked. Didn't think about certain features. Yes, that is again too much haste. Started solving the problem too quickly. As a result, the interviewer was dissatisfied that not all features were covered, which were planned for today, to cover in the market interviews. And lastly, probably the bottlenecks. Yes, that is, when people made a decision, they tried. It seems to them that everything is great here. Yes, that is, there is no problem. If they see it, it's so great that it's unclear how to solve them. It couldn't be better. Yes, that is, conducting a trade-off analysis. What options there would be for solving a particular scenario is no longer done, or they simply can't. So how do you approach such interviews? What should you do there? It's impossible to successfully pass a system design interview without a good plan, meaning it should be clearly structured. You need to know what is important, what is not, and how you should proceed with it. From my point of view, the plan for a system design interview is roughly as follows. First, we need to clarify the requirements, trying to understand what we are building, why, and then we need to do some estimations. Estimations are done so that you can justify your decisions. If you see that you need to store 100 terabytes of data, then we should have an end. The number of servers needed to store them. If we have gigabytes of data, then perhaps a phone would be sufficient. A mobile phone, and run the application from it. The next topic is about the system interface, meaning we need to understand the entry and exit points of our system. Then, the high-level design, where we describe how the system generally looks, and then detail, where we delve into the components and continue our discussion. We try to do all this, scale it, and finally, our concluding stage is the summary, meaning we actually need to review and present our entire solution. Perhaps some questions will arise, or you might have some additional thoughts, which you should address to us immediately at the end of the summary. It's just essential, if you try to fit this into a 40-minute slot, to ensure you have about 5 minutes left. For discussion questions, to linger on some points where there is uncertainty, someone might express it roughly like this, that for advertising, you need to spend at least 45 minutes. If you haven't spent this time initially, then we might not have built the right thing. Someone will likely be dissatisfied, probably the interviewer, and then you will be with the result of the interview, naturally. So let's move on to the points. So what is advertising and how do I clarify it? I personally divide advertising into two types, often called functional and non-functional. For me, it's about what the system does and what the system should be. It's simpler this way. Let's assume we entered an interview. We need a task. They tell us, let's build Facebook today. We start with something simple. What should Facebook do? Are we building Facebook, or are we building a system like Facebook? That's the main question, right? Because Facebook itself isn't needed. There's a game. We start discussing, what should the system do? Our task is to narrow the scope and understand which aspects are important in today's interview and which are not, because it can vary for different candidates. For example, we are building Facebook. What should the system do? Which part of Facebook are we building today? That's quite a reasonable question. Let's say, for example, the manager says, I don't know, comments on community groups. Let's assume we're not building the news feed today. Not the feed, it's not just about the news feed. Comments, likes, reactions, and other features, the pressure of posts, which features from the newsfeed do we want to build? It would be good to clarify such a question as well. Let's say they tell us the core functionality is loading feeds and creating posts. The next questions that might arise, for example, do we need to store uploads? Photos and videos? After all, this is an important part of the system and a large enough guard on storage. Let's postpone it to V2 for now, as it's not crucial at the moment. Do we need to display posts on the market, and how should they be sorted or ranked? Perhaps by interest or by the likelihood of your reaction to something like that? For now, in chronological order, meaning in the interview response we received attached to the screen, questions and answers. Not much protection for everyone, but overall, so you understand the meaning, how we are moving to the next story. Probably, if we are thinking about the feed of these posts, the question is whether we will integrate advertising or not. The importance of the feed. For example, in this interview, we will try to address this issue or this feature. Furthermore, do we need to make requests for friends, subscriptions, and so on? Because as we receive our news, we get them when we follow someone. So do we need to implement this part, or maybe it is available to us through a database or as a service? Let's assume it is available to us through a database. We can access it. Next, let's talk about what kind of system it should be. Because, for example, we would like to be a global system that is accessible worldwide, like Facebook is now. Or do we want to build something like, I don't know, Connect.ua, which once existed in Ukraine, a regional system, or like Facebook for America, a second clone? In this case, the interviewer is asking us to make it, well, primary. That is, we are building for global reach. How quickly do we need updates in our feed? For example, meaning how fast should the system respond to changes made? What latency is okay and what is not okay? It's clear that if it's a multi-regional system, the delays between regions will be larger, and within a region, smaller. You can specify what the expected values of this delay are, or what is acceptable. Next, it would be good to know what availability is needed, because high availability is not always a requirement. If we don't need high availability, maybe we need a strictly consistent system, and there will be completely different approaches in design. If high availability is needed, we understand that we immediately get eventual consistency, and the system is built in a slightly different way. And the story is as follows. How many users do we have? If we have, I don't know, 1,000 users, then, in principle, my questions don't need to be addressed. At any scale, this will be. At such a scale, almost any solution will work. And, okay, we have 1 billion, let's say, as the interviewer responded. In that case, how many posts do these people create? How much traffic do they generate? Maybe they don't write often. Maybe these are more like blogs on WordPress. Let's say people write 1 post a week there. Using Lyft as an example, what to do then? In our case with Facebook, that's about 10 posts a day, meaning 10 million posts a day with a total of 1 billion users. Further, and how many friends on average are we subscribed to? It's important to understand how many sources we need to pull this data from. On average, let's say 500. How many times does a person check their feed per day? So we have a system. Load, meaning we have 10 million posts per day. We write, but how much do we read from it? How often do we check our feed? Let's say on average 5 times. And after gathering these requirements, you can continue. I won't stretch it out to 10 minutes. Now, after gathering the requirements, we need to move forward. In general, you should record a summary for yourself, either on a board. If you come to an interview on site, or it will be, I don't know, in any tools that are for interview preparation, it will be endless. You draw your charts on a canvas there, and you can essentially secure it for yourself. A summary, so that you can return to these notes later and understand which of them you address. If we take the summary, we are building. We don't need Facebook News newsfeed. Photos and videos, we don't need post ranking. We do it in chronological order. It would be nice to have advertising. We do multi-region, latency. Within a region, it's approximately less than a second within the global network, up to 60 seconds. Durability is very important, because people will probably be unhappy if their posts disappear. Here, availability is slightly less important in this context, but overall, of course, availability should be ensured. That is, the system should not fail due to the failure of a single server. 1 billion users, 10 million posts per day, 500 friends, on average 5 views. The newsfeed is our starting picture, the next story we are moving towards. This is, of course, an estimate. But to do it somehow you need to at least have some idea. For example, your captain. That is, for example, when we are told a certain number of characters. How much space will this information take in bytes? So it's convenient to think of one character as 1 byte. You'll understand. There are also UTFs, and it's simpler with encodings and multi-byte encoding. But in general, it's usually enough to consider one character as 1 byte metadata. So what is metadata? Then we need to save a string in the database about something. That is, any role somehow needs to be estimated, and there can be many fields or few fields. It's difficult to estimate them. It very much depends on the data. Right, what do we need for the estimation? Then we take something between 50 and loaves, usually perceived quite normally. One photo is approximately 2 megabytes. 1 minute of video is about 30 megabytes. Once we've calculated how much data we have in general, we need to distribute it among the servers. What types of servers are there? In principle, in production, it's normal, meaning a server with storage up to 10 terabytes. You can pick such servers up to 8 max. Regarding memory, 256, 512 is normal. A terabyte is possible, but it's better to stick to 256, 512. So let's estimate our system, since we've already figured out how to do it. We have 1 billion users, we have 5 billion views each time the feed is watched daily. We have 10 million posts. The first thing we would probably calculate is the read-write ratio to see the nature of our system. We see an interesting figure because we have 500 times more reads than writes in terms of RPS. The same, yes, because it's related. But the absolute RPS numbers also give us some understanding. For example, 115 RPS is not very much. For writes, we can try to estimate how much space our posts will take in the database per day with 10 million posts. At 10 kilobytes each, that's 100 gigabytes, and about 3 terabytes per month, we can calculate our throughput capacity route for our traffic. That is, if we again load 1 billion times with 20 posts per day, well then the feed is also a list. Let's say 20 at 10 kilobytes each, that's already a petabyte. For writing those same 100 gigabytes, we set it up right after the stream, and then we move on to our system interaction points. Usually, you won't need to write a mobile application there, describe it, or any other clients. Of course, it's better to clarify this, but generally, it's often the point of interaction with your system. That's exactly the case with 5. And regarding 5, you don't need to go overboard describing it, some kind of thing there, hi about you, and all these entities described API points or their graph schemas and others are not needed. Most often, it's enough to define the API and the call, describe it as a function, its output parameters. Well, simply like, we have to create a post, this is in this is create post API. And we simply write which fields we will need to create this post. Here is also a basic set. We don't go into too much detail. The next API story we need is essentially getting the feed of posts here. Most likely it will be compressed. Well, because according to the story, there are many in the feed and all friends. We won't do it immediately, and the response will be essentially the entity of this post. After defining the interaction points, we move on to the section about high-level design, and when we talk about high level, I really like it. There was once a challenge to draw Spider-Man in 10 minutes, in 1 minute, and in 10 seconds. But if we apply this to our architectures and design, it is essentially, this is roughly what a person would look like, probably, after discovery, and like this only after joining after the first meeting with the client. And this is essentially the system design, meaning everywhere Spider-Man looks different. Therefore, when we do high-level design, we shouldn't end up with something that's already too far off. We've already made the mistakes we could have made during the interview if we drew it. Here, in system design and high level, we need to commit to which path we will generally take in the interview. Here, some adjustments can be made, some features can be added, removed, and so on, so that your interview process is roughly how they would like it to be, where you can showcase your skills. In this system, there might be no comments at all, and you proceed as you are. But overall, the high level should be high level. So what should it be like? If you imagine Facebook's high level, you might picture it like this. There are users. There's Facebook. The user asked something, and Facebook responded back. It's quite a primitive representation. But sometimes when you encounter systems or subsystems that you haven't worked with, well, for example, I don't know, some kind of image, just a send. We don't often do this, and now we need to build this component of our system. We can simply sketch it out neatly without delving into further details. This will be enough for us to move forward in the interview and explain the other frameworks, which might also be promoting the guards away. Well, such a primitive curtain probably won't do, so let's move a bit further. If we think about the design of any system, we can imagine it as layers. Well, no. It's not like I'm talking about a monolith there, Inter or something like that. But in general, there will be layers in any architecture, whether you move towards a monolith SOA or microservices. No matter what, you will still have a layer that initially receives data, meaning some part of our system, how to interact with it further. There will be some natural logic of this system. And after this logic, usually some kind of storage. If we are designing Facebook, we can start with this. If we are designing YouTube, we can start with this. If we are asked to create Google Drive, we will start with roughly the same thing. Since we are focusing on Facebook today, let's continue moving forward with it. So we have two APIs that we have defined. These are create post and get newsfeed. And then we can simply return inside some system and see how the events will develop further. So we draw our diagram. But applicable to our case, a person comes, calls the API, and after the API. Naturally, we will have some load balancing because we know we need to scale, and we need a scaling point. After the load balancer, we will have the applications, and following the applications and tasks, we have our storage. This scheme is sufficient for now. We can immediately note some questions that we will answer during the interview, either to ourselves or to the interviewer. For example, for me, when I already have a balancer, the first question is, which one? Do we need a sticky balancer or round robin or some other type? Well, the balancing rules. If it's a database, then which one? Is it a relational, a NoSQL solution, or in memory, or something else? So what kind of storage will we have? I wouldn't recommend giving specific solutions, like writing. For example, here we have Mongo. Here we have a balancer there, Nginx, or something like that, because there's no benefit, but a lot of harm. Yes, so we operate with abstract solutions and types of components, rather than specific components if we don't need them. And a good rule, good practice is always to commit to. At important stages, I drew and beer. Well, something like that, yes. All makes sense to you because you need to get information from the interviewer, or we are moving in the direction we should be moving. Maybe he has some plans, maybe not. In general, you need to kind of involve him in the interview so that he participates in your processes. The next stage is, of course, the newsfeed API. We are building it in the likeness of an existing API point. We reach it, and after it, there's a balancer. The question then is, which balancer, meaning these questions are still open, and we simply mark them on our architecture. That is, round robin, sticky, maybe it's the same balancer we already have. Maybe another one, it's unclear for now. So after the balancer, we have the application. The question is whether it's the same application or a different one. Good question, there's no answer yet. And then we will have a database. Again, which database? The next stage, well, let's assume there's a lot of logic in the application that can be developed through posts and through feeds. I will probably keep them as two separate ones. Separate application balancers, accordingly, I'll also make different ones, because there will likely be different balancing rules for accounts. It seems like that. For now, I'll make a common database. Let's see what comes out of it. So, this is the picture. Moving forward, we always commit to the information. That is, to the interview normally. Simply, if it's a race for you, then either everything is clear, or is he following your thought? Because if he tunes out, later you'll say something wasn't done. And from this point, in principle, you can move further into the detailed architecture. That is, such a high-level overview might be sufficient. It might depend more on the system you are building at the moment. For me, it's enough for now. That is, detailed design, what's there. We will try to describe some kind of request scheme. There, we will try different approaches to describe the processing of our data or interaction. There, we will try to choose a solution that we will stick with and explain its trade-offs, if there are any, and what they will be. They definitely need to be checked for sure. Our functional requirements, or if we are still meeting them, check the non-functional ones and look at some points. If they exist, determine if we will define a scheme. Defining a scheme is simply not necessary. Here, the maximum number of fields you can think of should be provided, but only a few important fields are needed. So in this document, for example, the user will believe so, and I'm sure there are 150 fields in Facebook. But in general, we only need, how many here? 5. Group, meaning the user can be a member of a group. Next is the user follow table. That is, we need to understand which users the user follows, which groups, and what they follow. So, in my current understanding, we will have the user's ID and the ID of the user, or group they follow, meaning it will be either one or the other. Sochi. The last thing is the post, meaning what the user uses, and this is also as simple as possible. If we start imagining the queries that will be made to these entities, then getting our subscriptions, who we are subscribed to, is quite simple. We took from the user follow table, and based on our ID, we got all the rows. There will be groups and users that we follow. Getting posts is a bit more complicated because we have either or fields. Well, at least in the current design, yes. And when we say we want to get all the posts, we need to take the user follow table and join it with the posts. By the user id that we follow, retrieve their posts, or by the group id that we follow, retrieve their posts. Sort this in reverse order by date to get chronological order and display it. What's the problem here? The problem here, of course, is with the speed of the query and the indexes, because it turns out we are either querying by user id, created add, or group id created add. We know that we have millions of posts here, and they will grow. There will be many. We know that we have approximately 500 friends. So, an index that changes the query is suitable. It cannot be created. Because we either have a user and a decree from one index, or a group decree from another index. And a general one will not work if we have either one or the other field. Percent. So, we need to move forward with this somehow. In principle, we could create a separate index for both the user and the decree, and for the group. The decree for this query will look approximately as follows. We will need to perform 2 select unions. We search by one index, then by another, merge them, sort them, and output the result. Obviously, the problem with such a query is that we will most likely run into our latency. That is, it is unlikely to work quickly and well with large volumes. Therefore, we return to our design and think about what we could improve here. We look at the design and see that these areas are overheated. And I would like to further discuss, probably on the mantras I use when there are performance issues. First, if we can avoid doing something, it's better not to do it. This is the first performance mantra. If something is slowing you down, just stop doing it. Secondly, if you can't avoid doing it, then do it once, and don't do it again. That is, during some process, do it less frequently. That is, try to avoid this critical path and offer the user other options, or postpone processing something that is long, expensive, and difficult. Or try to do it while the user doesn't see it, or do it concurrently with the current thread, or simply do it cheaply if you can't do it any other way. That is, if you've already hit performance issues and need resources, try to do it as inexpensively as possible. Basically, I described to you Brandon Gregg, a two-lapper from Netflix. You can visit his website to read about these methodologies. It's really great. I always use it. Roughly our situation, can we not load the feeds? No, we can't. Can we calculate them once and never calculate again? No, we can't. Load less frequently. We don't control that. The user sees it as many times as they open it. Doing it later is also not possible. Do it while users are not watching. Well, you can do something like move your load. How would that look? We have. Here's the picture. We ended with, and our problem now is that we're putting a lot of strain on the database. Perhaps to start with, we could distribute them across 2 databases so the problem becomes smaller, meaning posts are written to one, and feeds are served from another, which might look different and could be more optimized for reading. The only thing we're missing is some kind of connection between them, which connection we'll probably discuss further. Here, when we make such a move, I mean changing our architecture. It would be good to commit to it. So, does this strategy make sense before we continue trying? That is, we need to say something to the interviewer and understand that we're heading in the right direction. Maybe he will offer you an alternative option, or perhaps ask you how you see other ways to solve this problem if we all move forward. How can we transfer these messages from one pipeline to another, from one word to another? And all of this found a place to integrate, probably some kind of points or something like that. At least that's how I see it. That is, we can build Kiev after the balancer. In principle, it's an option, but why is it a bad one? Because our post hasn't yet reached the post service. We don't know if it will be created there or not. maybe a 500 error will occur, maybe a 400, or something else. Therefore, taking and transferring data from here directly into our feeds is still not the best idea. We can place masks after the post service, which is a bit better. That is, we have already validated the data at the application level, but we still don't know if they will be inserted into the database or not. There might be some error there, and copying them now also seems not very good. Perhaps do it like this. The post service writes to the database, then transfers it to our queue, and we further send it to the Jinx relation feed. In principle, this option is fine. The only issue here is the problem of this distributed commit, so to speak, meaning we write to the database and then to the queue. But what if it doesn't get written to the queue, meaning it doesn't reach us and the feed doesn't show up? Well, it's not a very reliable system, although, in principle, it works if we do it the other way around, writing to the queue first and then to the database. Looking at our ads, durability is very important to us, meaning if we insert into the queue and then can't write to the database, the ad disappears, but it appears in the feeds. Overall, the consistency suffers in a strange way. It looks somewhat inconsistent. We have some kind of discrepancy in the data, and we no longer have the user's post available. Let's go back and try to see where we can redirect this activity. We can try placing it after the database. That is, we either extract the data using an ETL process, regularly polling the database to check for updates, and then apply them to feed generation. Or we build some kind of stream. And in this situation, I probably like streaming more because it's so reactive. The recordings across the entire database came in as events and was streamed further into feed generation. I generated there. There are nuances with CTL, but there are pros and cons as always. With any rouse, I will probably continue with streaming and see how it could develop. We have a new entity, so we have a new database optimized for reading feeds. A feed table appeared where posts are packed. They are arranged in such a way that it's convenient for us to read, meaning we just need to sort in reverse order, submit, and we have it. All our subscriptions are already materialized there. How the query would look like, very simple, that is, select, don't criticize the asterisk, it's for clarity here, not for performance. And here we are approaching something again, not forgetting our movement towards the internet, that is, even a mix of the Spartan system. And something in this spirit, this mixer will sound quite often. We need to try an informal approach, but here is the next story. So we have this stream and we need to consider the other functional requirements. We had a story about advertising, which is usually based on context, meaning where the user came from and where they are now. It could be geolocation, it could be different devices, and during generation when posting, as if writing a post. Subscribers will see it in their feeds, and when they see the feed, the subscriber needs to be shown an advertisement there. It's not like happiness comes by, missed it, yes, so this thing that reaches out will likely reach out later with the feed service that provides and forms our view. That is, it would access the database, take all our subscriptions, check the current advertisements based on the user's context, integrate it into the view, and present it to our subscriber to see. So far, that's how it goes. Let's try to scale this solution. And when I talk about scalability, I have certain feelings about it, how the system grows and what solutions emerge within it. That is, when we have around 1,000 users, basically, one production server will be enough for us. I'm not talking about $5 virtual machines for cheap upgrades. A proper server will suffice. Closer to 10,000 users, we start to have things like replicas. We have several servers, and we will definitely have load balancers between these servers. Closer to 100,000, these users start to spread out a bit. Geographically, there is more load, more deferred tasks, meaning if there wasn't messaging before, it will most likely appear. Then some rate limits will appear because the number of requests increases. Most likely there will be a need to address the geographical distribution of our users. Closer to 1 million. If our services haven't reached 100 yet, they will become a forest. If we have been using SQL everywhere, then NoSQL might appear somewhere because the amount of data will simply become too large. Sharding will likely appear, and closer to a unicorn. We are already seeing the emergence of regional data centers because simply many people live in the same country, except for a few. Of course, our scalable picture, the first RPS that comes to us, I will go open. About 100 RPS comes there, and at that point, approximately 1,000. I think at the peak, that is, the average load on the system is not constant. People write more during some periods and less during others. Peaks can increase. But I would say up to 10 times it's clear that we need to scale our post. The service won't be a single instance. There will be several applications. And here we can already talk about what kind of load balancer we need. I don't see any specific reason why each user needs to post their entry to the same application service every time. Most likely, it will just be round robin. The database is growing. We have 3 terabytes per month. We remember the capacity. The servers there have about 10 terabytes. One server won't be enough. We need to scale. We shard the database, and when we shard something, the first question is how we are going to do it. I mean, what will our shard key be? A super important question here is our options for sharding by posts, such as we can put the sharding on the ovary, we can jar derivate by user ID, we can shard by credit. What are the advantages of sharding by post ID? Our posts are evenly distributed across our servers because each new post goes to a new server. Well, conditionally, the advantages, of course, are that it's uniform, meaning subtitles made by Dimetor Zok. We will have a uniform distribution across servers. What are the disadvantages? The disadvantages are that we have poor data locality, meaning when we need to search or read something, we will be saying, give me a list of posts from a user. We will go to all servers if you have distributed the posts. The next story is about user ID. User ID is worse in terms of uniformity than post ID because some users write more, some less. And depending on which users end up on which servers, the load on these servers will vary. That's why the uniformity suffers a bit, but the locality and cache hit rate improves slightly in the sense that if we are fetching posts from one user, we will likely go to the same shard. And the last credit is the most ridiculous one. Probably in this case, we will have it because the credit is based on the date. Posts with close dates are located next to each other on the servers. And it turns out that the last shard will always be overloaded because the latest posts will always end up in the last shard. We are always writing, roughly speaking, almost in one season. Cons, poor data distribution. Pros, of course, data locality. That is, when we need to get posts for a month from all users or all subscribers, they will approximately be on the same server. Since our task here involves writing data and it's conditionally write heavy, this option, of course, such an option is not very suitable. Post ID is suitable here as it provides better optimization for writing. We sharded our database, and next we have streaming. Streaming can be adjusted or left as is, meaning if we just leave it as streaming. This will be sufficient if it needs to be expanded. So what options do we have here? From the database, we want to receive an event indicating what we have. In any database, there is a cloud, some kind of block, or it's a headlock. That is, we can look for a place to integrate, meaning in different databases in different ways. Of course, one of the good options is replication, meaning we integrate into the replication protocol and receive this data. As for tools, well, again, tools. I don't recommend describing it, but in general, if needed, you can include something like Debezium here, essentially abstractions for different databases that can read, and fantasy replication, and essentially Kafka for streaming. So the pattern is generally called what? Change data capture. We captured our events and moved on to feed generation. In feed generation, we need to look a little more closely. Suppose there is a user and someone sends them a message. And this message reaches the queue, and from the queue, our feed generation service receives it, meaning we need to distribute it somehow across the feeds of other users, subscribers, so they know there is a new feed. So we take a subscriber, take the message, and place it in the database, addressing it to this subscriber. We do this for each one, meaning we have some multiplication happening. Initially, there was one post, and now there are 4. But since we know there are about 500 friends, it multiplies approximately 500 times. The number of posts in the feed will increase. We perceive the database of feeds as it is. So far, everything is fine. But what do we do when we have such users appearing on the platform? Yes, meaning when we need to multiply not by 500, but by 15 million or 150 million. Like Cristiano Ronaldo, for example. Let's say we have a user after a conference, and he posts to his subscribers, and we need to distribute this to those 150 million users. What is the problem here? Naturally, the problem arises with latency, because while we are copying all this, it will take a lot of time and might affect other users. Secondly, it's a lot of data, even for just one post. 150 million copies. It no longer sounds like such a sensible idea as it did before. And thirdly, we will encounter inconsistency. That is, someone will see this post earlier, someone will already react to it. The second user will see the reaction, but not the post itself yet. And it turns into a complete mess in the system, so we need to address this problem here. we will proceed. We will most likely follow our performance mantra and see what we can apply. And first, we might not do it. We can't do it. We need to do it. Can we do it just once? No, because we can't tell users to post once and then stop posting. Can we do less of it perhaps, but we probably can't show less to the users. We discussed whether we can do it later. I don't know, maybe, no. Can we do it while users don't see it? No. Can we do it concurrently with the main request? That's probably the option I would try. We take the service and request data using such a special visor. That is, we say that we don't stream all changes into our fit cache. We only stream those users who don't have a super large number of followers. Maybe we limit it to 1,000, 10,000, it doesn't matter. The rest we simply query the database for a request. So it turns out when a person comes and asks, give me the feeds are taken from the cache, and it checks whether the person is subscribed to a celebrity or something similar. If yes, then these feed posts are loaded at that moment. Requests of such queries will be quite numerous, but they will be small because they are targeted at specific users. In principle, they should work quite efficiently, mixing in our data, mixing in advertisements, and delivering to the user. In principle, we're doing fine. We'll move forward. Well, I think so further on. Just imagine what kind of database we'll have for feeds. That is, we have 1 billion users, we have 10 kilobytes per post, we have 500 posts, and we roughly estimate our storage is approximately 5 megabytes for 500 posts, which is about 5 petabytes, for some reason by 100 500, so this needs to be discussed. Of course, with the interviewer, ask how long we want to store histories, because it doesn't make sense to store history. We are designed for these types indefinitely, because it should still be perceived as a map. So I think that if a person is given to us, it has reached up to 100, 500, we can probably already go directly to the database and provide them with more historical feeds or come up with some other mechanism. That is, this feed cache should be of limited size. In our case, we estimated it for 500 post histories. For all users, this will be about 5 petabytes. On the servers, this will be divided into 10 terabytes, around 500 servers. Approximately with this, well, not super much, that is a lot, but not super much. Let's move on. We scaled our database. The volume is large. Most likely there will be some kind of New Year's solution. Most likely it will be sharded. What kind, we are not specifying yet. They are not asking. No need. If they ask, we will think about it. Shards appeared. As soon as shards appeared, the first question is, how will we shard? What sharding key, right? Also our same choices. Only in this case, the choice will probably be different. Since we have read optimization, how will we read? We read, it will be for the user's feed. That is, the question of distributing data by users already makes some sense. Data locality is important to us. When we read data, we would like to access one server, not many. And therefore, I would choose user ID here. I would also implement something like consistent hashing, probably, and virtual nodes when sharding, but I won't cover this on the internet right now. Read about it. It's a cool feature that allows you to keep data seemingly close, but also on different servers. That is a kind of compromise solution. Returning to our picture, next we need to scale the features, make several copies, and our balance will probably be sticky, because when a user comes and asks for a feed and then comes back for the second page, it might make sense to send them there. Application server. Looking at our ads, it breathed here, and overall we covered a lot. Design, name. In Facebook's design, we don't always have photos or videos. As requested, there's no post ranking. That is, we don't rank ads. There is multi-mode, but there's no latency yet. We have a normal multi-mode, still unclear. Everything else. In principle, you liked these. The white family of users, 10 million posts, 500 average friends, 5 views. And yes, everything is in place. How we will do it, or our architecture turned out like this. Let's imagine something, one mode. Yes, so let's not compress here. We have a stream. That is when a person, I wrote something, for example, it got into the database, it got in our queue. In principle, it's a good moment probably to branch off from this queue and send the message further to another region. If someone is interested there, it will go into a similar queue further. That is, between the Kafka instances, you can finish the queues about us so that the data flows. And then it will proceed to the generation of feeds. And if someone is subscribed to me from another region, they will in principle receive my feed. I think we've covered the topic of multi-region in principle. If we need to delve deeper, we can delve deeper, but I don't think it's such an advertisement that they want to reveal. maybe once. We look at the advertisement, we closed our issues. And the question is, did we build Facebook? Of course, we didn't build it, not even close. This is just on Facebook. It doesn't seem like it. So why was all this? What's the point of? The point was in seeing. And can we, as developers, technical leaders, architects, work with vague requirements? Requirements are not given to us. We need to figure them out, what we will do, how we will behave. Yes. Can we take something big and break it down into something small and manageable, into a smaller problem that we can solve? And can we provide steady progress? Yes, whether it's Facebook, Google Drive, or a nuclear reactor, just take it and move forward in small steps, dig into the requirements, and do it. Coordinate implementation options, and keep moving. The main thing is to provide progress, because often the big problems that developers in large companies solve have not been solved by anyone before. At your work, there are problems that no one has solved before you. Therefore, a very important trait is to simply dig into the problem and continue to tackle it. And of course, when you encounter a problem you're not familiar with, what I'm saying is don't give up. What are some tips for system design interviews? First, allocate enough time to clarify the requirements. The gathering and assessment of requirements are evaluated by the interviewer. No less than your system design. This is a very important step. If you gather the wrong information, misunderstand it, or do the wrong thing, remember, you are the rock star in this interview. You are leading the interview, and you have an assistant interviewer whom you can ask questions and clarify things with. But you are the one explaining how the system moves, is built and designed from start to finish, so don't miss this chance to showcase yourself. Start with high-level solutions and confirm them with the interviewer. That is, confirm whether this high-level approach is suitable, whether we can proceed with it or not, because at this stage, features can be added or removed. Your solution might change because of this. Focus on the things you know. That is, for example, you enter a system interview and they ask you to build a video transcoding service, but you've never worked with it. What do? You can always say, yes, I've never done video transcoding, but let's assume we have it and it somehow works. Draw a square inside. Let's build an API for it, and let's think about where we will store our source files that need to be converted. Let's think about where we will put the results, how we will notify users, and so on, where the configurations will reside. There are a lot of problems that can be solved within the scope of this task. The next tip, if you know a certain solution, meaning you feel like you've solved this task before, and you immediately start solving it the same way, you might be very wrong, because each interview is different. The interviewer can change the direction you're heading at any moment by adding something, removing something, or introducing a new requirement. That is, don't rush, proceed as if you don't know this solution. Gradually and with slow steps, constantly check with the interviewer or make sure you're on the right track. And this is super important. When you've made a step, well, not literally at every single step, of course, but after you've completed a section, confirm if everything is okay and clear to you. Involve the interviewer in the process somehow. Constantly check against your guidelines. If you forget some trick, you'll remember it later, you'll see it at the end. It won't be so easy to implement it then. Review, keep in mind what you still need to do, what you've already done, what you've completed, and what you haven't. And don't rush with your decisions, have some justification for your decision. That is, because large companies usually use Kafka, you don't need to apply it everywhere. Or because you think there will be a lot of data here, you don't need to immediately opt for a data lake. Calculate, make an estimate, and say, yes, indeed, there is a lot of data. Yes, indeed, we need it here. If you get stuck somewhere, really stuck, it's better to ask for advice and continue the interview rather than just fail it. At this point, I have gathered several useful resources that can help you understand how the process generally occurs. The design of the interview itself, what types there are, and to reveal more information than I provided in my presentation. But remember, there are no easy systems, design, interviews. They are all complex. They are made to be complex. So when you think you're going through hell, just keep going. We conquer the challenges. This was Oleksii Petrov with you.